Okay, and so as always, if you have questions, anything like that, feel free to use the chat, or you can unmute yourself and ask me a question directly. Yeah, and so as Tom was saying, I'm part of the team here. I work with Tom, and today we're going to be doing this. So getting started with Git and GitHub. So just a reminder for, I think we just had someone join us. This is in, we have a couple of people joining us still. This is in the reproducible R section. It's the second part. Okay, and you can just go to the slides here. Okay, and this is where we're starting. Okay, so first up, I need to explain to you what Git and GitHub are. Okay, so actually, as always, you can download all the material or the links to the slides. They should all be local if you download them, and everything is following the patterns that we used before in the introduction to R course. And we try and keep this consistent. So you'll be able to find what we're talking about. Okay, and if you want to be able to set your working directory, you can set your working directory using this. Okay, and that means everything will be local. Okay, but today we won't really be using scripts that you've had to download or anything like that. We're just going to be talking through some concepts, and then we're going to give you a chance to use Git and GitHub. Okay, so actually, as a brief kind of outline of what we're going to do today, like the first hour, I'm going to kind of introduce the concept of Git and GitHub. They are different things. I'll explain why they're different, and then I'm going to show you how to use them. Okay, and so in the first hour, I'm going to give you some like basic intro. Then normally we take a break for exercises, and so during this time, what we're going to do is give you a chance to install Git, because a lot of you might have Git installed. Okay, and we'll also want you to sign up for a GitHub account if you haven't done already. So it shouldn't be too arduous as an exercise, and then with the rest of your time, you should be able to go back and look at what I've kind of talked about and maybe try out some of these commands, like creating a Git repository, things like that. The second section, what we'll do is we'll start to talk about how we can use different graphical user interfaces for this, GUIs, and one of those includes Rstudio. And so that should, once we understand how Git works, that should help simplify the process. And most people that I know use Rstudio as their main way to do Git and GitHub. Okay, so let's get started. What is Git? Okay, so Git addresses this problem. So as you collect code for a project, you're always making these updates. And it's hard to know what version you're on. Like anyone writing a paper, right? There's version 1, then there's version 2. You've appended it with the date, or it's the final version, then the final version. And keeping an organization of these is tough. For anyone who uses Box or Google Docs, you'll notice that they've actually started to save each of the versions that you use. And so you can then look back at an older version of whatever Google document you have. And so how do we do this with coding and your scripts, right? We could use something like Google Docs, but Google Docs doesn't really accept R files, and it's not as advanced as some of the things that we want to be able to do with it. The other part, a big part about Git and GitHub is staying in lockstep with your collaborators. So most of the time, you're not just working by yourself, but you're working with someone else. Maybe you're building doing analysis for a paper, or you're building a whole pipeline to analyze RNA-seq or something like that. And you want to be able to stay up to date with the most current version. And so having a system to manage that across various computers is really important. And then when you create something new, how do you then share it with your collaborator? And so even if you're not working on something with someone, Git and GitHub provides like a vehicle for you to say, hey, look, this is what I've done. I'll share it with you. And this is pretty much what we're doing right here. We've created this course. We created it using Git, a Git system. We made it in R. Then we used Git to save everything that we're doing, and then we upload it to GitHub, so that you guys can see what's going on, see these slides, and have a look at them. Okay. And so what Git does is it's decentralized. So this means your whole team can have a copy. Even though I have Git on my computer, we can share something over using Git, and it will work the same in both computers. Okay. The whole idea is also collaborative, so we can both make modifications. You can set different permission levels, but really we can both work on the same project, and it doesn't allows us to work in tandem, okay, and efficiently. And then the big thing, which I've mentioned before, is version control. So it takes snapshots over time. So every change you make is remembered. And the really strong thing about Git is when you make these changes, it wants you to write a little message to say, I did this because of this. And so you then have a story surrounding how the pipeline was built, what was going on. And so anyone who then comes along and takes on your code, tries to see what you're doing, they will be able to see the full list of messages. Okay, and then they'll be able to get a much greater understanding than if they just have a script. Okay, yeah. So what are the kind of the principles behind Git and the way it was built? So it was made in 2005 by the guy behind Linux, and so probably most of you have heard of Linux. It's like a computer system. Some of you may even be running Linux on your computer, and they wanted to have a version control system for their Linux project, so making Linux. So as you could probably imagine, Linux is quite a big system that's complicated, and so their system wasn't working, so they just made a new one to support making this whole new computing project. And so they had this specific set of principles. Okay, so it needs to be fast. As you can imagine, working with any of these systems, if you want to be able to dig back into time, essentially, to see where your project looked like 2 years ago, to be able to save all these things and then be able to access them, that's quite complicated. And so you need a system that can work with these kind of files really, really quickly. It needs to be simple because, again, it's quite complicated what you're asking it to do. And so the simplicity helps with the speed. There needs to be an idea of branch development. And so what we mean by branch development is, say I want to work on something else on one project, and someone else wants to work on the same project, but they want to work on a different aspect of that project. So we can work on that same project at the same time, but we'll create 2 different branches. And we'll then work on it in parallel, and then eventually we'll take those branches and we'll bring them back to the beginning again. And we'll have both made updates, but would have been both being able to work independently without altering each other. As I mentioned before, it needs to be decentralized. So this is really to work with multiple computers, multiple peoples. And so for us, this is also really cool because decentralized also, I mean, it's going over the internet. It can be over a network, but for us, it can go over the internet. We can upload it somewhere once we're finished doing what we're doing, and then someone can download, and then you can be together working on the same thing. And then, yeah, as I mentioned before, for speed and simplicity, this is a really large project like Linux development. And so some of you may build huge pipelines, right? We have pipelines that we've built at thousands of lines of code. And for it to be able to handle that and to understand what changes are made, what each of the files are, what are their histories, is quite complex computationally. So it needs to be able to handle all these things. Okay, so what we're going to cover today with Git and GitHub is how you set up your own repositories. Okay, and so what we mean by a repository is basically a project or a directory or basically a folder. So it's going to be a folder in your computer that tracks all these changes that happen within that folder. Okay. How do you keep them updated, both locally and remotely? Okay, so by that I mean, how do you keep Git working both on your computer and also online in however you're sharing it. And then we'll talk about like ideas for best ways to have a workflow for developing code, okay? And workflows for collaborating with others. So these steps are all really important. And I really want to emphasize the importance of Git and GitHub, because if anyone is building a project, if you don't start with it, you'll probably come to regret it, okay? There's nothing nicer than getting to the end of a paper, for example, then you have to submit your paper, and they want to have all the code associated with your figures, which is becoming more and more standard, right? And once it's on Git and also on GitHub, you can then just share it by changing some of the preferences from a private repository to a public repository. And that's all you have to do, rather than collecting together these loose scripts that you've just saved in different folders here and there on your computer. This makes everything much more coherent. Okay, so I think some of the key concepts that we also need to learn, right, is what is the difference between Git and GitHub? And that will become clearer as we go. But Git is the version control system. So Git is the system that we're really using and working on. All that GitHub is it's a nice accessory for Git that holds all your data online. So it's designed specifically to work for Git, and it hosts everything online for you. You can create user accounts, things like that, which allow you to collaborate with specific people, but it's all about hosting your Git online, okay? And so often when people talk about Git and GitHub, it's easy to get confused about which one's doing which, but they have they are specific independent programs. The other thing we're going to cover is we're going to start off by talking about how to use Git on the command line, because I find this is the easiest way to understand how Git works. And then we're going to switch over to talking about how to use Git with different GUIs. Okay, and this is how I use Git on a day-to-day basis. So we're going to start off with command line just so we can get an understanding of what Git is and how it works. But then we'll try and figure out how to use it on a day-to-day basis. Okay. What we won't cover, making packages. Okay, so a lot of people use Git and GitHub to make a package, which, if you don't know, is just basically a collection of scripts that you can post publicly or privately, and it will do stuff. Okay, it's just a more advanced way of collecting your scripts together. We also won't cover alternate systems. Okay, so for those of you who maybe know or don't know, Git is just one example of many different version control systems. And a lot of the principles that we'll learn with Git apply to these other version control systems, but we won't be talking about how to use them. Okay, so some other examples are CVS and SVS. Okay, so we're not going to really talk about those, but it might still be useful to know how Git works so you can understand how they work. We also won't be talking about other repository hosting services, so nothing as an alternative to GitHub. Okay, the reason is GitHub most people use. There are alternatives that I've written here like Bitbucket and GitLab. Most of them run in more or less the same way. So again, the things you learn should be applicable to those, but I'd say 90%, this is just pulling a number out of thin air. Most of the people you'll run into who are using Git will also use GitHub, okay? And so if you want to create one account, this is probably going to be the most useful one. However, we'll talk about GitHub in more detail. There are some problems with that, but broadly, it's the accepted thing in the field. Okay, so getting started with Git. So first of all, interacting with Git. So we're not going to be using, I've mentioned Rstudio a bunch of times. We're not going to be using R and the R console at all today, okay? There are ways to do it with the R console, what you've been doing so far, but we won't be doing that today. Most of the time when you interact with Git, you're going to be interacting either the command line or through these GUIs, okay? And so to start with, we're going to talk about the command line. Okay, and so for those of you unfamiliar with the command line, I'll just show you. It's either called on Macs, it's called terminal, or on Windows, it's called command line. Okay, and this is the most base level way of interacting with your computer. It allows you to navigate around your computer and access all the programs within your computer. You can also access this with Rstudio, but not in the R console, and I'll show you that. Okay, so let me just show you terminal. Let me get a new window open. Okay. So this is terminal. Okay. And so terminal has a specific set of commands for interacting with it. But firstly, we just want to check to see if you have Git installed. And so this command should work if you're using command line or terminal. So you can just do git and -- version. Okay, and so it tells me that I have Git installed. Okay, because it responds with the version. Okay, so for any of you out there who like doing this along, to get this open, you can just, if in your search bar, like Spotlight or something, if you're on Mac, you can search for terminal, open it up, and then you can check with Git version to see if you have Git. Okay, and then if you're in Windows, you can also do command prompt. Okay, again, you can search for it, it's called command prompt. The alternative to using this is we can actually do it with Rstudio as well. Okay, so here we have our R console. This is where we do our R things, right? So we can do things like see what's going on with sum, right? But if you just look in this tab, there's a terminal tab. And so the terminal is also accessible through Rstudio. And so you might find it easiest to work through here. Okay. And so again, I can do Git version. It'll tell me my Git version. And so, yeah, we had a question from Calvin about what version of Git to use. You guys have a different version to me. I think it'll be fine. I haven't run into any issues with Git versions. I think I'm not entirely sure. You can, so don't quote me on this. I know it's being recorded, but I think Git is pretty static these days. Yeah, it's so the difference between 2.23 and 2.24 shouldn't make any difference. That said, if you start running problems, you just let us know and we can figure out what's going on. Okay, so you can see I've been interacting with Git here, and all I did was check how to check whether it's installed. If we go back to the slides, if you don't have it installed, there are instructions here. Okay, and so this is the Git book, which is a really good reference for anything related to Git. And so there's instructions for installing on Linux, Mac OS, or Windows. One thing you'll find, the easiest way to get it on Macs is by installing Xcode. And for Windows, there's a specialist kind of Git for Windows. It's not, like it says here, it's the most official build because Git isn't directly supported, or Windows isn't directly supported, but it works pretty damn well. Okay, so go back to here. You don't, as we mentioned, we're going to cover, we're going to take time to help people install Git if needs be during the break. So if you don't have it, don't worry, we'll cover it then. Okay. Instead, just pay attention to what I'm going to kind of go over, and hopefully some of the ideas about what Git is doing will filter in, and then you can have a play with it later. Okay, so when we want to set up a Git project or a repository, we have to use a command called init. Okay, so we do this, again, it's in terminal. And what you have to do is you create a folder. You make a folder that you want to be your project. You want this to be your repository. And then you enter that folder, and then you can initialize it. Okay, and so we have to use a series of terminal or command line commands to actually do this. So I'll just show you in action. So at the moment, we can do, there's a series of commands that might be useful. Like when you're on the command line, you can look at ls, and that tells you what's in your folder at the moment. So at the moment, I'm in my reproducibility, I'm in the download. Okay, we have a question from Matt. I think this is some install issues, and it's relating, I'm guessing Xcode. So that's Xcode is the command line developer tools. And so we can show you how to install that directly during the break. Okay,
great, thank you.
Okay, so anytime, yeah, when you want to do these kind of command line stuff, there's a ton of, we're not really going to delve too deeply in the entire course how to do this command line interactions, but it is, if you eventually get onto the HPC and start working on the HPC, it's predominantly how HPCs work. So it's a useful skill to learn, but it's not essential right now. But there's a few simple commands for navigation that can be useful. One of the things we need to do is create a folder, right? So what we can use is this command called make dir. So this is make a directory, and this is going to be our repository. So we can call this, I'm just going to call this test. Okay, so now if I look in here again, I'm using ls for list. I have this new directory called test that wasn't there before. Okay, so all ls is doing is just looking in the folder and my working directory. And so I create this new test, and then I want to change directory. So I'm in test. Okay. So use a cd command to change directory, and then I can enter test. Okay. So now you can see that I'm no longer in this folder here. I'm in test. Okay, that's part of the command prompt. And if I look in here, I can use ls again to list. And there's nothing in here because I just created this folder and there's nothing in here. And so what I want to do is I want to change this directory called test into a Git repository. And so to do that, I use Git, okay, init. So this is a common way of interacting with any program. In command line, you'll write the program's name, and then you'll write the command you want to give to that program. So in this case, we say, I want to use Git, and I want to initialize a repository. Okay, and so you can see it's initialized an empty Git repository here. Now I can look at it again, and it's empty. And so actually for people on Windows, I've been using ls. So some of these commands work in both Windows and Mac, Linux. Mac and Linux are always pretty much the same. Windows is slightly different. ls in Windows is dir, directory. Okay. So what is different about this repository I just created? Okay. So now if I look back at this, I can use the command ls-a. So this is like list again, but it's a special modified list, and it shows me anything that's hidden. And so now you can see that I actually have this thing called .git in here. And if I do ls-n, but I'm saying I want to look inside .git, I have all these files. Okay. So this is what anything that begins with a dot is called is a hidden file. You have the computers use them all the time for all kinds of stuff, but here we specifically created this Git folder or this Git repository, and what defines a Git repository is this .git section. Okay. And so that's the only difference. You have all these files in here. These are a bunch of basically flat text files, and they contain tons of stuff about that tracks your history. This is basically where the business of Git is happening. Yeah, and so Windows, you can use, I think, dir/ah should do the same to reveal these hidden files. But it doesn't matter too much. We're just looking inside. You can see all these simple plain text files, and that is what makes Git special. So the next step is you want to actually set Git up to be yours. Okay, so you're going to be making edits to files, and it's tracking that. And if you're going to collaborate with people, you want it the tracking to track who's doing the edits. So if I make a change, and then Tom makes a change, when I look back at the history, I want to know who made the change so we can talk about it. And so, again, in terminal, you can change your config, okay? And so you can add a username. In this case, I'm adding a username brcru, okay? And you'll want to add an email, okay? And you can also check what you have already. So maybe if you've already been playing with Git, it already has some of these things. So you can check. And so you can see if I do git config and then add in global and user.name, it responds. So if you do it without giving it a new variable, it will just tell you what's already stored in there. So this is my username. Okay. And so we do that here. So I added this username brcru, and then you just write the same command in, but you're not assigning to it, and it responds brcru. Okay. And so this is important for connecting to GitHub later. When you set this up, you'll want this to be the same ID that you give to GitHub. And you want this to be the same address that you give to GitHub. Okay, so this is just setting up your Git. We've done nothing exciting really so far. This is just all configuration stuff. So next we want to actually use the repository. So let's switch back to here and I'll show you in action. So I want to create a folder or I want to create a file. Okay, so I'm going to create a Readme file. And so to do that, I can just use touch. What touch does is it doesn't add anything, it just creates this file. The file is empty, but I'm just saying this exists. Okay, so now if I use ls again, you can see now I have a Readme file. Okay. And if I go to git status, okay, I can then see what's going on with my Git. So I'm going to say I'm looking on this branch. There's been no commits yet. And I have one untracked file, and it's that README. So I added a file. Git knows it's there, and I've checked that using the git status command. But it's untracked. It doesn't know what to do with it yet. It's not saving it at all into Git. It just knows it's there. And so there are 3 stages of Git, or 3 states. Where we are right now, I'd say this is just a simple working directory. We've made a change, we've saved that change, and Git is aware that there's a change. But Git is not involved right now. So the only change that's happened is in your working directory. It's happened on your local computer, and Git knows it's happened, but it isn't doing anything about it. And so this is what is considered to be untracked. What we then do is we do something called staging. So when you stage it, the untracked files or any changes you've made are added to what's called the staged area. And stage files are not added into your Git repository yet, but they're ready to be. They're like, these are files that we're about to add in. They're primed and ready to be added to the repository. And then the final stage is we commit. So once you've made all the edits you want to make and all the files that are relevant to what's going on are staged, then they are committed together. And the commits are what puts the changes into your repository. And so once it's into your repository, it's being tracked. Okay. So anything that you change to your working directory, anything you change to your working directory and you then stage, that's not actually incorporated yet into your Git. Okay. It's being actively monitored by your Git, but it's not incorporated into that repository, and the history isn't being monitored. So this is kind of complicated. It takes a while to get your head around, like, why do it this way? Why not just save the document and it's done? So there's a specific culture around this, and there's a culture to making edits, and there's a culture around how you should do Git right. Now, I'm going to give you some kind of rough guidelines that I think are right, and I've seen other people post similar things online. But there is also no hard and fast rules with this. This is everyone finding their own comfort zone and how it works with them comfortably and how they collaborate. So broadly, you don't commit everything that you change. So say I find a typo, I don't necessarily need to commit that straight away. I might save it, I might stage it, but if I'm saying reviewing my code, I might find more typos while I'm reviewing. So why not commit them all together as this one big commit that's like, I have reviewed my document and I'm going to commit everything together. Okay. And so that feeds into this idea that each commit should be a nice little story that you can tie up with a bow. It's very straightforward. So for example, if I add a new function to a pipeline, say I have an RNA-seq pipeline and I add a function at the end which makes a volcano plot. That's really great. Okay. And so I could work on that for several days. I make a lot of edits and saves, but then once it's working and I'm happy with it, I commit it as one. Okay. But maybe I'm not just committing that change, but maybe if I have a README associated with that script that describes how to use the script, I can also make a change to the README to say, this will also make a volcano plot. And so I've made changes to two files. They're relevant to each other. They're one little story. And then you can put a commit where you commit both those at the same time. Okay. And so really the commit and the message associated with the commit is what's telling the story of the changes that you make to your document. And so the aim is to create something that when other people look at it, or more times than not, when you look at it yourself in 2 years' time, you understand what you were doing on that Tuesday afternoon. You understand the thought process, the rationale, and the kind of the aims that you were going for. And so this rule that I saw, someone tweeted this rule, and I thought it was really good for this, is there shouldn't be multiple clauses in your commit message, right? So if you're doing something and you're doing something else, maybe that commit is too complicated. Maybe you're doing too many things. Okay, so it is that balance of including enough where you're not making hundreds of commits that are kind of totally unnecessary, where some could be bundled together, but you don't want to be doing like 3 or 4 things with each commit. You want to be doing one coherent thing. And so, yeah, it's all about balance. You'll find it the more you do Git, you'll get this idea. You don't need every single minute change logged, but you want every step logged along the process. And so, yeah, like I think the key thing is deliberate and thoughtful. So it requires you to think a little bit more than you would do normally when you're just saving your scripts as you go along, but it pays off in the end. Okay, and so that is something I want to emphasize. This is a time commitment. It is more complicated than what you're doing normally, but it does pay off in a big way as you go. Okay, so now we understand that, like, we may have a rough grasp, not necessarily understand, but like a rough grasp of what Git is doing and these 3 steps. Let's do them. Okay, so if we go, I go back to sharing. I can do, if you remember, I did git status. And we have my untracked README file. So the first thing I want to do is stage it. And so to stage something, we do git add. Okay. And I want to do my readme.md. So now if I look at git status again, you can see things have changed. Let me make this bigger. So this was it before, and this is it now. And so it's gone from an untracked file to changes to be committed. Okay, so it's staged and it's in the right place. Okay. And so I might then want to commit it. And so when I commit it, I'm going to just say git commit. And so it's nice, simple, git commit. And I want to add a message. So you do -m and you will add a message. Okay. So I'm going to say I've made a readme file. Okay. And so now when I enter this, oh, did I do? Oh, I didn't. I did an extra quote mark. Okay. That should still have worked. So you can see I ran git commit and I gave it this message, which was made a readme file. Okay. And so I created this, and now if I go to git status again, oh, I didn't run. Okay, give me a sec. I think that this did something funny because I did an extra quote mark. Okay, there we go. So we've created this commit. Okay, here. It has a code associated with it. And it tells you about what changed. So I did one file that's been changed. There's been no lines inserted, no deletions. Okay. And so that is my commit. And so if I ever wanted to go and look at this commit, I could use this code that's associated with the commit to go look back at it. And now if I look at git status again, there's nothing here. Nothing to commit, working tree is clean. So that's good. Okay, so let's switch back to the slides again real quick. So I added the README. I committed it. Okay. And so you can have different versions of the same file in both your committed, staged, and working directory version. And so it's a good idea to try and keep track of what each is doing. Okay, what changes have you made? And so to do that, we can use the Git Diff command. Okay, so if we switch here, what I'm going to do is edit the README file. And I can actually, so there is a command here that says echo, but I can actually do it directly in here. So if I go to the file, I'm here, I'm in test, and this is the README file I created. Okay, so I can open that up, and I can just write in a message. Hello. Okay, I can save that. And now if I look at git status, there's been a modification, and now it's in red. And so there's been changes, and they're not staged for commit. Okay, so they haven't been staged yet. I can also run git diff. And this command tells me what's going on. So it says, hey, you've got this README file here. And in the new version, you've added this line, hello friends. So Git Diff allows you to track the changes you've made. Maybe it's over one file, maybe it's over many files. Sometimes you forget what changes you've made. And before you want to stage it or commit it, you want to double check. So I like the change I made. So maybe I'll do git add and readme. Okay, so this is staged now again. So it's now gone from changes not staged to changes to be committed. So it's staged. And I can run git diff. And it doesn't see anything. Okay, because what git diff is looking for a difference between anything that is in your Git folder and anything that is or in your Git directory and anything that is in your working directory. But at that point, once it's staged, it's starting to consider your README as start to be part of your Git working directory. So if you want to specifically look at what's happening with the staged files, there's a modification to this, git diff staged. Okay, and so now this is comparing what's happening at your staged versus your actual Git repository. Okay, and it's exactly the same changes, right? It's just looking at a difference because we've moved the file from your working directory to staged setting. Okay. So that's the commands git diff. Okay. And then we can just commit this. Okay. So I just added the commit here. Pretty straightforward, just git commit. And again, you get this kind of hex code along with your message, which we just added. Okay. So now we want to start to look at the power of this. If you have a project that you've had over a period of time, you might want to be able to look back at what you've been doing. So to be able to do that, you can use the command git log. Okay, so I'll switch back. Git log. Okay, so when I do git log, it tells me what I've done recently. So it tells me we have this commit. This is the actual number for the commit. It was made by me. You can see my email address. And it was made at this time, and you can see what the message is, right? And then you can see the previous one before that. And so this, as you can see, is kind of wordy. So there's modifications of git log. So there's one called git log one line, and it compresses this down to a single line. Again, you get the code and you get the message. And there's even another modification of this. There's maybe somewhere in between. It tells you a little bit about what actually happened. So it's a simple one line, but it gives you some stat information. So in this case, it tells me that a README file was changed, but no lines were changed. But in this one, README file changed, one line changed, and it was a plus. So we added a line. Okay. So that is the introduction to Git. Okay. And so I think what we're going to do now is quickly introduce GitHub and give you an idea of how Git and GitHub work together, and then we'll take the break after that. Okay. And so I hope you have a rough understanding that Git is basically allowing you to track these files over time, who's making the changes, what those changes are, and to have a narrative associated with the changes. Okay. And so this is all happening locally. I've shown you it's happening on my computer. Well, GitHub is this online presence, and it's a repository hosting service. And so this means it's really good for backing up your code. It's really good for sharing your code. there's a lot of tools specifically built on GitHub that make it easier to collaborate. And then you can turn these repositories to make them public. So any code supporting a project, you can show to others. Or if you are looking at someone else's work, there's a good chance they have the code on GitHub and you can go and look at them yourself and then try and repeat their work or use their methodology. So the benefits of Git versus other services. So I touched on things like Bitbucket and GitLab. It has direct web access, so you can directly go from Git to GitHub very easily. Some other tools require you to have like an installed thing on desktop. It has these things called issues and pull requests, which we'll go into. You should be slightly familiar with issues, but these add into this kind of ecosystem of GitHub, which make it much easier for collaboration. It has probably the most extensive features to support. There's a lot of automated systems that we use, for example, to actually like build these courses. They have these systems that will just, when I make a change to the course, it will automatically build all the slides for me. And to that end, it supports lots of different file formats. A lot of other programs don't support these file formats. Markdown is probably the most important of these, and we'll cover that in the reproducible reports section. And there's a big community aspect. It's almost like a social network. You can follow people, you can follow specific projects they're doing if they're public, and you'll be able to see what people are working on, communicate on it, and there is a sense of community there. And one of the big drawbacks, though, that it almost has a monopoly, and so this can be an issue sometimes. For example, like a couple of years ago, where because it's a US-based company, there were several embargoes brought in place against US companies working with foreign countries that were deemed not okay by the US government. So places like Iran, Afghanistan, places like that. And so a lot of scientists and researchers who had things and their work all on GitHub, they got all blocked because of that, and they couldn't share, they couldn't collaborate with people. So because it has a monopoly, it can lead to issues like this. So that's just something to be aware of, but also like it is the best service, so what can you do? Okay, so big thing to remember, everything about Git is local and offline until you tell it to go to a remote. Okay, so when we talk about online, we're talking about a remote. Okay, and so this is a remote site into which your Git is pushed. So you push it up to wherever you're hosting your code. So the example here we're going to be using is GitHub. And so we have to adapt our Git to tell it where to push these things. We have to give it some configuration, and then it will be able to connect the Git to the GitHub. So first up, you'll have to create GitHub accounts. Again, we'll do this in the break in like 10 minutes. Then we can create a repository. So here is my GitHub, okay? And so what we want to do most of the time is you want to create a new repository. So this little plus symbol here, you can do a variety of things, but most of the time I want to create a new repository. Actually, just as an FYI, I have my computer on dark mode, so that's why it's black. Most of you probably, it's white. Doesn't matter, it's fine, don't worry. Okay, so I'm on this repository. I'm going to link it to test. So I'm going to call this test. Oh, I already have a test. Let's call this test2. You'll be able to come up with a better name relating to your project. Okay, but this is just me doing a demo, so it's fine. You can choose whether it's public or private. Okay. Okay, what's the difference between creating a repository and creating a project? So GitHub has a very specific idea of what a project is. They can be useful, but I'd say most of the time for what you're doing, projects have other tools available to them, but most of the time what you're going to be wanting to do is just create a repository, and that you can put your project within it, but it's a very specific GitHub thing, okay? If you get into GitHub and start using it more, then you can start looking to projects. Okay, they have things like timelines and stuff like that associated with them, so you can like track a project as it matures. But for most of the stuff that you'll be using, it's not as useful. Okay. You can also do things like add a Readme file. Okay, these can be useful. I created one already, so it's fine. Add a Git Ignore. I'll tell you what these are later. Choose a license. So if you make it public and you're making code that is other people might use, you might want to protect the code in some way intellectually with a license. You can also use templates if you have a template. So I have several templates. So if you create a template, that can be cool, but it's fine. So I just create this thing. It's called test2. I'm going to make it public because it doesn't matter. That is a good, actually, another point is when you actually, I'll talk about it at the end. Okay, don't worry. So I've created this repository. There is no code in it at the moment. And it's telling me about how to interact with this. Okay, so it has some instructions here, but I'll run through them for you. The big thing here is this address. So this is where your project is. It's at github.com. It's associated. This is my user ID. And it's in this test2.git. Okay, so I want to be able to tell my local Git where this is. Okay. Okay. And so you can also get that in various other ways. If you've already put some stuff in here, you can also it is up here. If you click on the code with the green button and the download symbol. Okay. So what I'll do is I will switch over to my Rstudio. And so I'm still in my test directory. This is actually an important concept. You can have lots of different repositories on your computer. The repository that's in action is whichever one you're inside. Okay. So I have hundreds of Git repositories, but at the moment I'm only interacting with test because I'm inside test. Okay. And so this is where I've put it. Okay. And I want to add this, add a remote, add this as a remote. So I do Git Remote Add. So I'm adding this remote. I'm going to call this remote origin. And this is the path. So I can just press enter in theory. Okay. And now I have a Git remote. So I think if I do Git remote, it tells me I have origin. Okay. If I do Git remote origin, oh, it doesn't return it. That's fine. So yeah, I have origin now. Okay. Just as a note, most people call their remotes origin. It's a convention. You can have multiple remotes associated with a single Git. Okay. So if you have multiple places you're saving this, that's totally fine. But the main branch, the main repository that you're working with on GitHub, generally people call it origin, and so you'll see that a lot online, and it might be useful for you to adopt the same thing, just so it makes more sense and it kind of fits with what everyone else is doing. Okay, and so I have some changes, right? I have some stuff that I did to my test directory that's not present up on my repository on GitHub. So I have it on Git, but I don't have it on GitHub. All that's on GitHub is this empty folder called test2. So what I can do is I can push it up there. So the concept is called a push. And so we do git push -u origin master. Okay. So I'll switch over to this. Okay. And so if I run this, what it's going to do is it's pushing all the changes I've made up to origin. And it's specifically adding it to what's called the master branch. So we're going to cover branching a little bit later. There's multiple branches you can make, but the main branch is called the master. This is like the trunk, and you can have things breaking off the side, but you always want to protect the master, and you want to be able to, like, the core changes that you want to be present in everything should be on the master. Okay, so you can see it's now uploading. It takes a little time. It gives you some message about the upload. When you do this for the first time, it may require passwords and stuff like that. I have it set up so it knows my password. There's ways to do this setup, and we're not going to really cover that in the course, but you can look up having SSH keys so that it does it for you. Okay. And so now if we switch over to our GitHub, and if I refresh it, it now has this folder, Readme, and it has Hello Friends in it. And the nice thing, as a Readme file, this actually displays visually when you look in the repository. Readme is quite often you add in a description of all the code that you have in this folder. More often than not, you can do edits on here. So if I wanted to just say, I don't know, add a smiley face, I can. And I am doing a commit, and it's all on GitHub. So I'm just doing an update of my README, committing it directly to the master branch. And so I made a change, and that's also added to the Git, okay, on my GitHub. But this, you could see, like, changes like this, it's not very convenient, and you can only make changes to one file at a time, okay? So it isn't necessarily the recommended way to do things. But it's good for, like, a quick fix. If you have a typo and you just notice the typo and you want to quickly fix it, you can do it there, okay? So I added a smiley face. And so now that my thing is changed, now that my GitHub is changed, my Git is behind, okay? And so this is another one of these key concepts. You have changes in your GitHub and changes in your Git, and you'll want to be able to keep them in register. So I did a push to put my things from Git onto GitHub, and you do a pull to go from GitHub back to Git. So we can just use the same command. Okay, and we get it back. And so you can see now it's even updated the README, and I have the smiley face locally. Okay, so that is our pause point. So that is as much as we're really going to cover in specifically working on the command line with Git and linking it to GitHub. The next steps, we're going to start to work on Git and GUIs. Okay, and so this means there's a GitHub Desktop utility, which is quite easy to use, so you don't have to use the command line as much. And there's Rstudio's way of doing it as well. Both of them make life a little bit easier. Okay, and so I'll tell you how to do that, and we'll tell you about some advanced utilities. Okay, and so we're going to restart that at 3 o'clock. Until then, what will be really good is everyone signs up for a GitHub account, and everyone installs Git. Okay, so you maybe want to start with Git, then get a GitHub account, and try and maybe do the steps that we've covered in the course today. So all I really did was I created a folder, I added it, I made a modification, did some commits, play around with the staging, play around with committing so you can get an intuition over what that does. Then try connecting it to GitHub, and then pushing and pulling. Okay, and so if anyone can get to pushing and pulling, that would be super impressive and really good. And yeah, so we'll start at 3. There are no specific exercises, but there are exercises at the end of the session, which will cover everything. Okay. I'm going to turn off the recording. Okay, so we got to Git and Gits and GUIs. Okay. And I have the chat up. Sorry, the chat is way too big. There we go. Okie dokie, I think we're set. Okay, so hopefully you have some idea at this point roughly what it means to use Git. We've only used very simple toy example of that Readme file, right? Where we made some very minor changes. We added a file, we added a line. But when you apply this to your actual data set or your actual scripts, your pipeline as it changes, for you, you can use it for your exercises as you complete your exercises. You can see how it's saving the changes as you go. It's saving a log of what the changes mean. And you're able to look back in time to look at them, okay? And we've kind of got an understanding of like the 3 stages. So if you remember, you make a change to your local working directory. You then stage it. So Git is now looking at it. It's ready to be implemented, but and Git is very aware of it, but it's not saved into your repository at this point. It's saved on your computer, but it's not saved into the repository with all the working history and things like that. And then you commit it and you have this message, and now it's logged. It has a place in your archive essentially, and it's there for the runtime of that repository. Like you can, if you keep the same repository and you run it for 20 years, we could look back to this point using Git. So hopefully, yeah, we've aimed to just give you some understanding of how to use it and things like that. Most of the time I use Git though, and GitHub, I'm not using this command line, okay? The commands I've shown you are like the most simple, straightforward ones. And a lot of the time, this can be taken care of with a GUI. So a graphic user interface with some nice point and click, which makes it nice and straightforward, okay? And so there's 2 main ones that I would talk about, but there's actually just hundreds out there. We're going to talk about the one that's actually made by GitHub. So GitHub have their own GUI. And then Rstudio has Git integration. So this is the one that I use all the time. But I know some people prefer the GitHub one, so I should give you a quick demo of both. And so with these, it makes it just a little bit easier to manage what you're doing with GitHub and Git. And they work by sitting on top of the Git that you've created. And they just take care of all the commands for you. So under the hood, it's exactly the same thing. And in fact, I could create a Git repository using Rstudio, for example, and then go to that using command line and interact with it in the same way as I did earlier today. And it would work in exactly the same way, even though I created it using Rstudio. So it's really nice for the day-to-day stuff. When you get to the more complicated things, say something, you have an error, or you want to do something much more complex with Git, and I'll show you a couple examples at the end of the session, and then the command line is often the way to go. But for your day-to-day stuff, Rstudio or Github Desktop are great. Okay, so I'll just show you GitHub Desktop. There's links to downloads. You should have Rstudio, but there's a link here to GitHub Desktop, and you can download it. Okay, so let me open up my GitHub Desktop. Here we go. So this is my GitHub Desktop. Okay, so I'll try and I won't flick as much between the slides here, but I'll try and follow the pattern of the slides. But I'll do it live with showing you the tool. Okay. So I'm just sorting out my display so I can see everything at once. Okay, so this is my GitHub Desktop. And this is kind of the opening screen. And so you can see it lists your repositories that you have in GitHub Desktop here. Okay. And say I want to add a new one, I can clone a repository. That's what it's called when you get something from github.com. And it's attached, because it's a GitHub's repository, it's attached directly to GitHub. And so it lists out, these are all my repositories. Okay, it's got all of them, everything that I have access to. So, for example, I have a repository for, let me search Matt. Matt, who's here in the course, the Heights Lab. I have all the work I've done with him, I have in this repository here. And so if I clicked on this, I could then clone it and it would be attached to my, my local tool here. And then it will work with GitHub Desktop. I can also alternatively add something that's an existing repository. So we can have a look through here. So this might take a sec for me to find the right place, but we created a repository earlier in here called test, right? So we created this. This is a GitHub repository. So I can open this up and then I can add it. And so now I have test. And if we remember, it's called test locally, but test2 on GitHub. And so it's linked to the GitHub. And it can understand this link between this local and the remote. And now that it's connected, I can do things like I can check out the history. And so it can see all the changes I made. You can see I did this, I did this. So this is similar to Git Log, right? But it's much more friendly. I can also make some changes. So let me quickly, where do I have it? So I'm just in the background, I've made a quick change to my Readme. Okay. So I just added in the words goodbye. And so now it's recognized this. And so if you remember, I've made a change. So I've changed my working directory. I've changed the file locally. And so then I want to stage it. And so with these GUIs, the way that staging work is you just do a tick. And so now, as soon as it's ticked, it is staged. I can also, if I, give me 2 ticks, I can more. Okay, so now if you look back here, I just did a quick copy of that. And so I have 2 files now, they're exactly the same. And I can stage them individually, or I could stage them together. Okay, and when they're staged together, I can then commit them together. So I can say I've done Readme editions. And you can add a more extensive description here. It also allows you to add co-authors. Say you worked on it with someone, but maybe they didn't do it on their Git. But, maybe they were sitting in the room and you were writing it together. It allows you to add it here. So it adds a few more features that are a bit more user-friendly. And then I can do commit. Okay. And so that was me doing the whole process of staging by doing the tick boxes, and then committing by writing the message and pressing commit. Okay, and it's all still saved in my history. I can then, again, do push. And this pushes those changes up to my origin. Okay, I have nothing to push up anymore, so it won't give us the option to push. If you make changes to your remote, like on GitHub itself, it will give you the option on your desktop to do pull in exactly the same place. Okay, so if we actually look at this one, this has an example of there's 2 commits to pull. Okay, so this is another demo example. So I can do pull, and then there's a merge issue. Okay, so we'll get into merge conflicts in a bit, but yeah. So that is using the GitHub Desktop. Okay, was there anything else I wanted to show you? So we did pushing. Okay, so that was GitHub Desktop, and that pretty much in like a couple minutes I was able to show you how to do everything we did this earlier on this like GUI interface, how much easier it is for this kind of day-to-day stuff. And it's all handled behind the scenes. It does exactly the same thing, but it's just handled by the program. And so to set everything up, they have really good documentation. There's some links, and there's also some other links here for helping to use the software to its maximal amount. Okay. So now we'll switch over to Rstudio. Okay. So you might notice up here in this pane, if you've installed Git, there's some extra things up here now. You should have a Git tab. You might have to restart your Rstudio to do that. And we actually have to create a Git aware project first. Okay, so how do you create a Git project? So what we do is we can either go to here and you can go new project, or you can go to file, new project. Okay, is there a project here? No. So what I have to do is I go new project. Can everyone see this insert here, the pop-up? Yeah, fantastic. Okay, so this pop-up, it gives you 3 options. So if you want to just create a project in Rstudio, you can just do a new directory and stuff like that. But if you want to create a version controlled one, you can click on the version control option. You can then click on Git. And what this will do is allow you to create a new project based on something that you have existing on GitHub. So if you remember, on GitHub, we have, let me show you. Okay, Esther Sanchez, it says Git not found. So that means your Git is either not installed yet, or Rstudio hasn't found your Git. So you can try, if you have installed Git at this point, you can try restarting your Rstudio, because maybe it just needs to restart. Because quite often with these programs, they don't find their like constituent like dependents and things like that. It might not be able to find Git unless it's there when it starts up for the first time. It's similar with terminal. You won't be able to find Git until you've both installed Git and then restarted terminal. I don't see the Git tab in Rstudio. Yeah, you might not see it yet, but we're going to create a new project that is Git aware, and then the Git tab should pop up. Okay, so here I have my repository that we created earlier, right? It has these things that we just pushed up. So I'll just copy this. Okay, and so this is the address to this, if you remember. So the way it works with Rstudio is you always want to create the GitHub remote first. You always want to go onto GitHub, create a repository, and then you can switch back to your Rstudio. You create you go to new project. It has to be version controlled. And then you can paste in the URL here. Okay. If you want to change the name, you can. And then you can pick where you want to put it. So I'm just going to put this on my desktop for now. Okay. And so what this is going to do is it will create a project. I'm going to open it in a new session. It's going to create a project in my desktop, and it's going to be called test2. Okay, and this will be a Git repository. Okay, so it's just opened up a new window for me, which I'm just going to switch to. Okay, and so this, you can see it's called test2. You can see inside it, we have our files that we've been using. Okay, and we have our Git up here. Okay, when it does this in Rstudio, it automatically creates some stuff for us. So it creates these files, which are just configuration files. We'll actually talk about Git Ignore a little bit more, but this one is just an R project file. And so it's all set up.
Sorry, Matt, I have a question.
Yeah.
So we created already a folder that was test2 in our computer, right?
Yes, I already have one of those on my computer, yeah.
So if we were to link this to GitHub and then go back to our studio, would we have to use like also different folders for these, or is it the same? Sorry, I'm a bit confused in that.
No, that makes sense. So with Rstudio, it likes to do things in a specific way, and I'm pretty sure you cannot just directly link it to the existing local copy. So kind of what we were doing this morning was kind of demoing how it works using the regular Git commands. But when you're working with Rstudio, I'd say the best workflow for that is you start with GitHub instead of starting with local. You start with GitHub, create the repository on GitHub. It can be empty. It can have stuff in it. It can just be whatever you want it to be. And then you create the project, which will be where you work in locally. Okay. So what I've kind of shown you isn't like, I'd say, a typical workflow in the fact that I've got made test2 locally. I pushed it up and then I'm pulling it back down into somewhere else. That isn't how typically I work. But this is kind of just to demo each of the tools separately.
Perfect. Thank you so much. So you recommend that when we start a project, starting GitHub and then moving it to the local directory. Thank you so much.
Yeah. That's actually, yeah, that's how I would start. Okay. So yeah, you'll just be able to create a new repository on GitHub. It could be whatever you want it to be, and then you can create a project in Rstudio. That's how I work most of the time. Sometimes I do it the other ways, and it's important to know how to do it in the kind of most basic way with Git. And so I think knowing that gives you a better understanding. Okay, so right, I'm just going to refine my slides so I know what else I need to show you. So we've created this repository, and so now we have access to this tab. Okay. And so it's very similar to what we did with the desktop tool for GitHub. You have these ticks, okay? And you can see it has a label that says staged. So these additional files that Rstudio gave me when it made a project, I can stage them both at the same time. I can look at Diff here, and let me see, I'll show you Diff. So this is Diff, and Diff shows me the difference. So I can click on either and see what these contain. Okay. So both of these have a bunch of stuff that's been added. Okay. I can also click on commit. Okay. So this actually opens up pretty much the same place. Okay. And you can see they're still staged. I can still unstage them at this point. Okay. And so if I stage them both, I can then add a commit message. So I can say, I set up Rstudio project. Okay, because that's what these files came from. Then I can commit. And you can see now my branch is ahead of the origin master by 1 commit. So I just did a commit and it was pretty straightforward. There's pull and push options here. So I could push these options straight up right now. Okay, so that's pushed and now it's gone. And there's also ways to modify, like if I have a bunch of stuff staged, I can unstage everything. This is nice when you have like 20 things staged and you don't want to have to go through and tick everything. Also, if you make a commit and then you realize you missed something, you can also add this to the previous commit if I make another change by clicking here. So it adds a bit more utility, some shortcuts and some like some quality of life improvements on being using the command line tools. Okay. The other part is here. You can look at the history here. So that's the little clock. And so I can see what's changes I've made recently. And you can see all the commits up here. I only have 5. Yeah. Okay. So those are the 2 tools. And so now I'm going to walk you through some ideas around like your general workflow. Okay. And so hopefully by now I've explained like all the different ways I typically work with Git and GitHub and the GUIs and options that you have. And so this is like an idealized way that you can work with Git. Okay. I would say I match this idealized workflow 50% of the time. But if you are ever like training to work in like industry or any software development, this is like what you should be aiming for. If you can implement it at least some of the time for the projects that you really care about, it will help you a great deal in just having a good rigorous workflow at least some of the time, right? Okay, so this is kind of your best practice. Either for when you're collaborating or if you're just working by yourself. It's really good for both. And so first, when you're doing some analysis, maybe you can raise an issue on GitHub. Okay, and so we've seen how to do that. And so if I go to here, I can say, I can go to here, I can raise an issue, new issue, and I can start an issue here. Okay. You can then create a branch to address that issue, okay? And so I'll explain a little bit about branches in a sec, but what we're going to be doing is splitting the project, and we're going to create a side branch where we can start to play around and try and address whatever issue we've raised up. We can then add the commits that we need to address that issue in that branch. Then we do something called a pull request, and what that does is it closes the branch back to the master. You can then review the changes and get feedback on that pull request. And once everyone's happy, those changes that are in the pull request are then officially merged back in. So the pull request is just, hey, I want to do this. And then the official merge happens at the end. Okay. And so I'm going to walk through and explain all of these steps. And so, as we mentioned, the first one is the issue. So we can have a new issue. And so you can write, typically you write what the issue is. So you can say, hi, I found a bug in the code. And then you can add more details. And you can say line 22 has a bug. Okay. And so then you can then submit the issue. You can assign people to do this. So if you're working collaboratively and you think someone will be better suited, you can assign an issue for that, assign them to that, and then they'll deal with it. So we can submit that issue, and then I can look at my issues and you can see it's there. Okay. So it's really simple. You can do this to say you've got a bug, but you can also have an idea for a new feature, an idea for like, you're doing some analysis, you're saving all your analysis up here, and you're like, well, actually in my lab meeting, my PI suggested that I also include some volcano plots. And so this could be a good way to manage your, like, what you're working on. Okay, so then once you want to address this new thing, you can do something called a branch. And so the idea of branching is you really want to maintain the original piece of analysis. You really want to maintain the original code. You don't want to risk damaging it in any way by making changes. And you're going to try out some experiment. You're going to experiment with some stuff. So what you do is you create a new branch, and what it does is it creates an additional copy of that repository. So then you have 2 repositories, okay? But it's all kind of contained under the hood, and they know that they're related to each other. They know that there's this point in which they split off, and they were exactly the same before this point, and after this point, they can differ. And so this shared history means that later on, you can then merge them back together. And so the key point when you think about branching is the master branch should always be considered what is published, what is core to the repository, what is unchanging. Well, any changes while you're testing them out and figuring them out should always be on the branch. This protects your master. Okay, so in these because this is kind of some like more advanced ways of using Git, I have the code here on the left-hand side for how to do it, and I also have a picture of how to do it in Rstudio. Okay, and so for working on Git, there is a git branch command, and you just give it the name. Or you could use the git branch command without a name, and it will tell you what branches exist. So in this case, I used the command git branch new branch. This built a new branch, and then I ran git branch, and it told me the 2 branches are master and new branch. Okay, so to do this on Rstudio, we have this here. Okay, and so you can see that we have this little box, and it has like a branching icon. And so when I click on that, I now have an option to make a new branch. So I can just create a new branch. So we're making a new, that says new branch. Okay. If you have multiple origins, you can choose which one it's associated with. And then you can also choose to sync it with the remote. So what this means is automatically, if I sync it with the remote, GitHub will also push up a new branch. Okay, so GitHub will be aware of this new branch as well. And so I can go create. Okay, and so it gives you some information because you basically pushed it up to GitHub at the same time. Okay, and so now, if you look here, you have 2 branches. You have a master and you have a new branch. And you can switch between them really easily. Okay, it's simple as that. When you are using regular Git, to switch between them, you actually have a special command called checkout. Okay, and so if you write git checkout new branch, this means you switch to the new branch. Okay, and so then if you then type in git branch, you can see something's changed here. So if I'll just go back here to give you a clue, you can see that there's a little asterisk. And so when you type in just git branch on the terminal, it tells you which branches are available and which branch you're on at the moment. And so the little asterisk shows you which one you're on. And so when we did git checkout to new branch, we've now switched over to the new branch. And so that means once you're on the new branch, any changes you make, anything you add and commit, they'll only be attached to this new branch. And the master will be unchanged. So it's a really good way of doing some experimentation with your code, trialing stuff out, without damaging what exists already, until you're sure and very happy with the changes you're making. It is also good to mention there's other forms of checkouts. And so This is getting to the more advanced side of Git where maybe I wouldn't use Rstudio for this. What you can do is check out specific commits or check out specific files, okay? So most of the time you use checkout, you're switching between branches. But if you go to a specific commit, what you're doing is going backwards and forwards in time. So you can use something like Git Log to look back in your old commits, figure out which, like maybe something went wrong, and you'll be like, oh, I edited this file at this commit, so I need to go back to see what I did. So you can then, once you've done Git Log, you'll be able to figure out what your commit ID is. And you can then use that Git commit ID to go back to that point, check out what you did, and just have a look, okay? If you realize something is wrong, you can then try and make edits to fix it. But this ability to like travel backwards and forwards in time in your version history is really, really useful for tracking things that have changed. Another way you can use checkout is if you give it a file name. So when you've made, say, local changes to a file, say I updated the Readme file, okay? I added some stuff. It hasn't been staged. They haven't been committed. I've just made changes. And I've realized those changes are really stupid. They were a mistake. What I can do is if I git checkout and I do git checkout the file name, what it will do is it will roll that file back to the last commit. And it will erase all those local changes I just made. Okay, so it's super powerful. Again, ways to roll back time. And there's lots of other ways of using checkouts, but this is just kind of a taster. Okay. So let's switch to this. Oh, actually, I should explain this first. So we've talked about raising an issue now, and then we talked about creating a new branch. Once you create the new branch, you'll make a bunch of changes. You'll figure out what you needed to do to fix whatever was going on. Or you've got this new feature you want to add, new piece of analysis that you want to add. You've got figure 1D and you're adding that to your analysis report, whatever it is. Once you've done this, you'll want to then pull your branch back into the master, okay? And so to do this, there's a specialized function of GitHub that manages this, okay? And there is ways to do this within Git. So there's something called Git Merge that you can do. But the GitHub equivalent, which is called a pull request, is a little bit more complicated, but it gives you a chance to actually be more collaborative and have this extra level of review. So the way that Git Merge works is it just directly takes your branch and it will merge it straight into your master and done. A pull request is similar to creating the issue in the first place. You create something on GitHub and it's saying, I want to take this branch and put it back into the master. What do you think? And so if you're working with someone, you can then get them to review your code. Or if you're just working on your own project, you can then use that as a point to review what you've done. Once you're happy with it, you can then add some text to say, this is my intention here with this pull request. And so again, it's a point where you can add to the kind of the culture surrounding your repository and how it's working, and to add annotation so you can tell the story of your code. And so I'll show you how this works, but first I need to actually make some changes. So say I have this guy, I've realized that there's a bug, and that bug is I have 2 copies of the README, so I'm going to just delete it. Okay, and so I'm on new branch. I'm going to commit these changes because we're doing this on GitHub. So we want to get the changes up to GitHub. So I'm going to add a note. So I'm actually removing the accidental duplicate of Readme. Okay. And so I'll commit that. And I pushed it up. Cool. So now if we go over to here, we can go to my GitHub, go to test 2. And I can see that I've just made a change to new branch, and it gives me a little pop-up. And it's saying, the branch is now different to your main master. Do you want to compare it and do a pull request? I can also, at any point on GitHub, I can actually look at a new branch. So I can, here you've got the branching here. I can click on new branch. And I can see that the README is gone here. Okay, and so I can use this shortcut here to start creating a pull request. I can also click on the pull request tab. Okay, so again, it's saying, give me a nice little shortcut, or I can just do new pull request. If I click new pull request, I have to specify. I want to bring my new branch and I want to merge it into my master. Okay, so the directionality is important. There's a little summary of what's going on. And this tells me the difference. Okay. So whenever you do this with your folders, it will show you what things have changed. It's the same as Git Diff. And I can create the pull request. And so it will autofill this if it can. But it also gives you the opportunity to add more things. So I can say this was just a demo of how to add commit. It's not a useful file. Okay. Again, I can click here and I can ask someone to review it. Okay. I'm not collaborating with anyone in this repository, so it has no suggestions. But let's see. No, it'll only suggest people are allowed to review from people who have access to the repository. But if you're collaborating together, then you can do that super easily. You can add things like labels to help index if you have lots of different kinds of things happening on a project, if it's very active. And then ultimately, I will create the pull request. Okay, and so at this point, it means I can review what's going on. Okay, and so similar here, we created the pull request. We added some comments. And this is a point of review. So if this is public, anyone can see this. If it's private, anyone in the repository can see this. And so people can add comments. So people can have a conversation about what this pull request is. It can be lots and lots of a series of comments or a discussion. And so I can say this looks good. And it's just a comment. Okay. And so people can add more and more things. There can be a discussion around what's going on. And then when everyone's happy, whoever is reviewing it is happy, you can click on Merge Pull Request. Okay. And I think this works. If I say it's related to, if I do a £, I can say it's related to, I found a bug in the code. And so now, that issue is tagged in as pull request, so it's all linked together. And then I can press confirm merge. And so it's successfully connected together. Okay. And so this branch that we just created is no longer useful. It had its purpose, but it's now merged. All the changes have been merged back into the master. And so we can delete this branch. Okay. And so that is the pull request done. There's no more open pull requests. This is all empty. And also if I go to issues, I can see that this is now attached to this issue. And if I wanted to, I can say pull request finished this issue. And then I can close with the comment. Okay. And then you have no more open issues. The issues, everything is maintained, so it's under closed, so you can see what's been done in the past, but it is no longer active. Again, with the pull request, you can see it in the past, but it's no longer active. Okay. And so, again, I mentioned this Git Merge and pull request. They're essentially doing the same thing under the hood, but pull requests allow you to have this conversation over GitHub, which becomes really important for collaborating and any collaborative work you do, because then each repository you can have this kind of culture surrounding it. What do we talk about? What do we make sure is correct? What parts are we concerned about? And like I mentioned, you can do this on your own repository. So when I was starting to figure out how GitHub works, I used to follow this like workflow to a T, so I can have an understanding. Now I'm a bit more loosey-goosey, and I do it sometimes, but it varies. Okay, so one big thing you might face is something called a conflict. And so a conflict happens when you do a merge. And so far I've been painting this idealistic model where everyone's cooperating, it's super easy, it's collaborative. But if people are working together and they actually try and edit the same line of code, this can be an issue, okay? When you try and merge it together, Git won't know which one is the right one. So to get around this, you have to do some conflict resolution. Okay, so I can try. Let me give me a sec. I'll try and create a quick conflict to show you, because I think it will be clearer. So if I go to my GitHub, if I edit the README directly on here, let's say I delete the smiley face. Okay, and I'll commit that directly. Okay, so on GitHub, there's no more smiley face. Now, if I change over to this, okay, one thing to remember, we just did the pull request. So I'm going to go to master, and then I'm going to do, so now we just updated everything because I pulled from GitHub. If I go to, oh, yeah, I'll add the smiley face. Okay, I just made a mistake. So I pulled too late. Okay, so I've added a smiley face here. Add smiley. Okay, and then I will go back to online. Share. And then I'm actually going to make this a different one. Let's make a frowny face. Okay. Now, okay, so sorry, that was a little quick. So what I just did was I updated the README. So on GitHub, it's a frowny face. On local, it's a smiley face. And, oh, sorry, my Slack is going wild. I'm going to quit it. Okay, and so what I can do now is, say I do a pull, it says there's a conflict. Okay, and so what a conflict looks like is this. It asks you to fix the conflict manually. And so it's recognized that this line and this line are the same line, but there's been two different edits. And what you have to do is go in and see the two different lines are demarcated by this saying head, this bunch of equal signs, and this index here, this number. And so we can decide which one we want. So whenever you have this merge, you fix the merge by saying, I want to have this smiley face, so I'm going to delete this, delete this. And this is going to be the final version. Okay, so the conflict is fixed. I'm going to save it. I'm now going to commit. And so this is a merge fix. Okay, and so I have these two commits, and then I'll push it back up. Okay, so we just fixed a conflict. Okay, and so the thing with conflicts to remember is it's just you have two pieces of code, they don't match between the two files because two edits have happened simultaneously, essentially, from Git's viewpoint. And so the way to find them is to look for this, the head, the equals, and this. And the top part will be one half of the code, and the bottom part will be the other half of the code. And you have to decide which one you want to keep. Or maybe both of them are wrong, and you can just delete this whole lot and write your own answer. Okay? But while this exists, and this exists, Git will be unhappy, and it will recognize that there's a conflict. Okay? Oh yeah, by the way, yeah, I realized that you can't see the commit window when it pops up. I've tried to, when it's relevant and interesting, I've tried to show it, but when I'm trying to speed through something, I've skipped that step. So sorry if that was confusing. I'm trying to just balance how much to show you and not get fed up with all this sharing. Okay, so we're nearly there. What I'm just going to quickly show you is just some other samples of other useful tools that are useful for Git. Okay, we're not going to go into any detail really on them, but there's some useful commands. First one is forking. So similar to branching, you can fork repositories. Okay, but this is a GitHub specific thing. And so when we're forking, we're not just branching some repository that we're working on, we're going up to a repository that someone else has that's public and forking off of it. So if we go to, say, Rockefeller University, okay, and we have this really cool package called Profile Player. And this is created by Doug in our team, and it helps you visualize genomic signal over given ranges. Okay, and so what I can do is I can press fork, and I'll fork it to my private repository. And now, in my own repositories, okay, this is my big list of repositories. Oh, it's still loading. I have profile file, okay? And what this is a branch of basically a digital, like an online branch of Doug's profile player from the Rockefeller University GitHub, but it's my own copy. And so this is nice because then I can play around with the code that underlines it. I can try and break it, or I can add features. And we don't have to worry about the original version at all, similar to like the master. And then when you have a fork, just like with a branch, if I make a change, I can then do a pull request to ask for it to be pulled back. And so this means you can work collaboratively with people who have existing projects online and start to contribute to them. And so this is often the way it starts. If anyone has any open source projects or things like that, it's often how they start to get involved, is they realize there's a feature that they want to have in a tool, and then they build the feature themselves, and using a fork, they build the feature, and then they'll ask if it can be integrated back in. So that is forking. it's really nice because you can then really get to grips with someone else's work. Yeah, I think I covered most of it. It's you're allowed to adapt it or deploy it, do whatever you want with it. The code is there. I guess the big thing you need to do is check for a license first, because if it's got some kind of private license that protects it in some way, if you're going to then try and use it for something that the license prohibits, then you might get into trouble. Okay. But you can always message the developer, whoever owns the repository, and talk to them as well. One thing that's really useful is if a user notices a bug, or even it can even be a typo, right? Instead of messaging someone, say, "Hey, I found a typo," you can say you can fix the typo on a fork, do a pull request, and then all they have to do is accept the pull request, and it will be fixed. And that way, you have a history of working on GitHub, which is important, and they have less work to do. Okay. The other file that I mentioned is the Git Ignore file. It was created by Git. It was created by Rstudio when we made a project. And so what the Git Ignore file is, it writes a list of files that you don't want to go up to GitHub. And you don't want to be tracked by Git at all. And so when we work with large files, this can be really important. As I kind of covered, like if you're tracking the history of things, if you have like a BAM file or something that's really, really big and really, really long, it might actually be too much. And it might not be useful to do like version control on that. And so what you can do is you can actually just list out this. So like my genomes.fastq file. You don't want to be putting the fastq file up on GitHub, and you don't want to be tracking it with Git. It's too much memory, too complex. Okay, it's too big. So you could just put it in here, and Git will know to ignore it. Okay. You can also use wildcards. So like I work with lots and lots of different files, and I don't want to have to write out every single one. So I could just put *.fastq, and that means it will know to ignore every single fastq file. Okay, so the Git Ignore files are really powerful and very useful. So the example I give here are BAMs and bigwigs, but yeah, fastqs as well. And the Git Ignore file is typically in the top directory. Okay, so that in our case, it's in the test2 directory, right? Or test. But you can also create Git ignores in subdirectories, and whichever one it's closest to takes precedent. So by adding a exclamation mark in front of something, you can actually negate the fact that it gets ignored. So say I have a really small fastq file, okay, that I really want to pay attention to, called my small fastq. Yeah, my small.fastq. I can put that in it. And now it will pay attention to that because it will ignore the previous rules. And I could create that Git ignore in a subdirectory as well. And it will pay attention to whatever it's closest to. So if I create a folder within a folder, if there's a Git ignore in that folder within a folder, it will pay attention to the one that is on the same level as. Okay, nearly there. Moving files can be an issue. If you move a file, Git can get confused about what the file is. And you want to, or like, say you've spent ages making this script, it has all this history associated with it. You don't want to move it and then it think it's, and that often what Git will think, you deleted a file and then you created a new file. And when you do that, you've deleted all this history. So you want it to know that it's actually the same file, it's just moved from A to B. So Git has a git move function. Ooh. But which works pretty well. And that's fine if you're moving a single file. Alternatively, what you can do is manage it either through Rstudio or using the git add -a command. And so the key thing with this is whenever you're moving something, you need to make sure it's going to initially consider it as a deletion and an addition of a file. But as long as you stage everything at the same time, so as long as you stage both the deletion and the addition of the new file, it'll figure it out that this is actually, you're moving file a file from folder A to folder B. Okay, and so you can do that using the Rstudio's Git interface. As long as you tick both at the same time, it will know that you're moving it. Or you can use git add and the -a command. Okay, and so if you do git add -a and then do the dot, it's going to add every change that you've done, and it's going to stage all of them. And the -a will help it figure out there's some files that are moving in here. So moving is really important so you don't lose history, because it's really easy to drop the history and then you just lose everything. And you can always get it back, but it's a pain in the butt. Once you delete a file, it's not removed from Git history. It's just there's still a record of that file and everything you did with it until you deleted it. So there is a Git Rm, which removes the allows you to either remove its entire Git history or just remove it from being tracked. So it's similar to .git ignore. It depends on what parameters you give the rm. There's Rebase, which is an alternative to merge. And it's really important. Say you have updates to your master, but they're not present within your branch. Okay, so in this case, while you're working on your branch, the master's actually been updated, and so the branch and the master are no longer in register with each other. And so what Rebase does is it allows the changes you made to your master to be added to your branch without it having to be collapsed back into the master. Okay. That might be a little confusing, but it's a really useful tool. And if you ever get into that situation, Rebase is what you're going to be looking for. And then reset allows you to rewind back staging and commits. So I've touched on that as a possibility. I've shown you how to do checkout, so you can go and look at these different stages, but reset allows you to actually turn back the time permanently. And so with that, I'd say the Git book, which we showed you at the beginning. This is a really, really useful resource for anything Git, okay? And so for your day-to-day, Rstudio is going to be super great. It will allow you to do all the basics. Anything more complicated, you want to go back in history, do stuff like that, you want to use the Git command line, and this will tell you how to do it, okay? And there's a lot going on. And as you can see, it also has some stuff with GitHub and other tools as well. So it is very comprehensive, this book. I use it a lot. Okay, so there's the GitHub book. Other nice tools. This one is a really cool tool. If you want to get an idea of what this branching looks like, and if you are quite a visual learner, maybe this isn't loading. Okay, you can run Git commands here, and it will show you what the branch looks like. So if I do Git add, Git commit. Okay, so I did a commit and it's moved up one. I did another commit. Okay, but then if I do git branch, new branch, git commit, or I could get checkout, new branch. Okay, so this shows you how I did a bunch of commits, I did some branching, and how they separate. So if you're a visual learner and you're struggling with understanding how this branching is working, this could be a nice little tool to play around with to help you understand that. The GitHub help page is also super useful. It covers both Git and GitHub, but mostly GitHub. So it's really well documented. And then the last point is, yeah, getting confident with the collaborative side of GitHub is really tough, especially if you say you're in a lab and you're the only one who's doing the programming and you're not really collaborating. But it maybe is a skill you want to learn. So there's lots of different stuff on GitHub, and some of them are less serious. So you can start to practice. So there's one that I saw pretty early on when I was learning how to use GitHub. And it's just full of jokes, dad jokes. And they're all bad, but you can submit them. You can do a pull request. You can go through all the things that we talked about. And they'll be added as long as they make them laugh. So you'll get to practice in a very low stakes environment. Okay, and I think pretty much the last thing is we focus on R, right? But we haven't talked pretty much about R at all today. That said, there is ways to use Git and GitHub through R. So we've shown you how to use it with Rstudio, but R itself, there are specific packages. And so if you get into programmatic interactions with Git and GitHub, there are these packages you can get into as well. Okay, so we have some exercises that you can run through. The first section covers running Git on the command line. Okay. The next section covers, the next part covers connecting Git to GitHub. And then the final section encourages you to do some online collaboration through GitHub with one of the repositories we have. Okay, and it's very similar to the dad joke one I just showed you. So I'll be around for a while yet, and maybe I'll go through this close to 5, maybe. I think we normally we have like an hour left, so maybe I'll go through this at 4:45 to explain what the answers for these. Okay, if you need any help along the way, or you have questions, I'll be around. I think Tom's also still around, so he'll be here to help. If you can have a go at the exercises, you'll get a better understanding of what Git's all about obviously when it's in your own hands. And yeah, let me know how it goes. The other thing is, this is only the second time we've run this course. So if there's specific parts that you found confusing, let me know, because I want to make it better and easier for people to understand. And it is a little bit different to some of the other stuff we cover. So your input is really useful. Okay, so I'm going to pause for now, and yeah, we'll be around.
Sorry, Matt, one question again. So do you recommend we use the Rstudio Git integration platform or the other one, the GitHub Desktop, or this course in general?
I prefer the Rstudio. Mm-hmm. That is a personal preference. The GitHub one has greater capacity. It has more things you can do with it. Mm-hmm. I really like the fact that I work in R, I have all my files that I'm working on, and I can do the GitHub, and it's all one thing. Mm-hmm. Okay. And I find it much easier that way. Okay. But some people prefer the desktop because you can do more things with it. So I'd say, yeah, especially when you're starting off, I recommend the Rstudio.
Perfect.
And then if as you get more advanced, you might find the desktop's more useful for you.
Thank you.
Cool. Right, I'm going to pause here, and yeah, any more questions, let me know. Okay, so we're going to get back to just going through some of these. The exercises. So just give me a sec. I should have been prepared and had them up. Okay. And what I'll do is I was actually going to go back and we'll just get, let's get the answers so we can look at the answers. Okay, so in the first section, we want to use, this is for using command line Git. That said, if you didn't use command line and you went with Rstudio, that's totally fine, but some of the logic of it may have been a bit tougher. So what we first did, create a new folder called GitHub training and turn it into a Git repository using the Git command line. Okay. So all we need to do is we need to make a directory. You can also do this interactively using Finder. Right, so I can, let me grab terminal. Okay, I'm gonna share my whole screen for this just because it's gonna be easier. Okay, and here we go. Let's see. Okay, hopefully you can see my whole screen. Oh, okay. So first up, we're going to let's change the directory. Let's go to the desktop. Okay. So I'm on my desktop now. That's wrong. That's all my desktop stuff. Hopefully there's nothing incriminating. No. And I'm just going to make a new directory. GitHub training. God, I'm terrible at typing. Okay, so I just made a new directory. It's called GitHub training. There's nothing in it. I'm going to change the directory into it. Okay, this is all the commands I showed you at the beginning. And what I did was I then initialized the Git in it. Okay, so I made a Git repository. If I look, there's nothing in there, but if I look and I do, oh, it's not, it's A. So I use the ls-a and it shows me the hidden files. Okay, if you remember, if you're on Windows, it's the dir to look at what's inside, but it doesn't necessarily matter. All we're doing is creating this Git repository. Then what we want to do is we want to copy a, we want to create a Readme file. So we did touch read, we use touch. Okay, so now there's a Readme file in there, and we're also going to copy something in there. All right, then create a Readme file, write in your favorite movie. Oh, Twilight Zone's not a movie. Okay. But we can put a movie in. Cool. So I'm just going to put Jaws in. That's a movie. Okay. Then, so I did it here via echo. And so what echo does, I think, is it just takes this, I don't know, I'm pointing at my screen like you can see it. Okay, it takes echoes of this section. So this quotation, it echoes it and puts it into the README. Okay, so if we, just as an example, and then look inside, you can see it's added Twilight Zone onto the end. Okay. So, and yeah, I'm just looking inside it using a reader. Cool. So we create this folder. Then what we want to do is add a specific script into this. Okay, and this script is in the download of the course materials from this section. And Carolina just pointed out that this is actually wrong. This is, yeah, the scripts are not present in the data directory. Okay, so let me see. I've used CP for this. CP stands for copy. Again, you guys don't have to do it all this way. I'm just very confident on the command line because I've done lots of practice to command line. Okay, pretty sure I downloaded it. Okay, that's what it's called. Downloads RU. So there's RU reproducible. That's what it downloads as. And then if you go to our course, okay, and then it's under scripts and it's called day of the week. Okay, so I now have the path to the first section for CP, and then for the second section, I'm going to copy it directly into where I am. So I can use just a dot, and that's my placeholder for copy it to where I am. Okay, then if I use ls again, now I have the day of the week script here. Cool. If I use git status, you can see I have 2 untracked files that have both been added. Okay, so that's the first section. We haven't added or committed them, but I will do in a sec. But first, we have some questions. Esther Sanchez says that they get some errors when they push. SRC ref spec master does not match any error. Failed to push some refs. Okay, that's an interesting one. I do not recognize that. What I might get you to do, Esther, is if you can bear with me while I run through this, run through the answers to this, then maybe we can have a look at what's going on specifically on your machine. I hope that's okay. Because this seems to be a very specific error, because I don't recognize it. It's not a common error. Okay, so we're doing very similar to what we did before, but what I've said is in the questions is add and commit the README and the R script separately. So we've made these 2 changes and we consider them to be not related to each other necessarily. So what I'm going to do is I'm going to do git add README and then git commit. Created README. Okay, and then I'm going to do git add day of the week. And then git commit. Okay, so I'm just committing these 2, and I'm going to say that this is add script. Okay, so now if I look at Git log, you'll see I have 2 different commits. One where I was adding the README, one where I was adding the script. Next, I want to add this to a remote. So I'll have to go to GitHub. Where's my GitHub? Okay. Let's go to my GitHub. And I'm going to create a new repository and test 2. Okay. And I'm going to do git remote add origin. Okay. So I'm adding this as a remote so that my local Git can connect to it. And so now I could do Git push. Okay. So that's that first section. It pretty much follows what we did in the before. If you are pretty sure you're going to use Rstudio, you could also do this the Rstudio way pretty easily. And so the big thing, like that's a change if you're doing Rstudio versus with the Git command line tool, is you'll first want to create your project. And so that means you're first going to go onto GitHub, you'll create the repository on GitHub. So we'll go here, we'll create this. Then we'll go to Rstudio and we'll create the project. And once you've done that, you can then start to do these things like create files. And you can do that also all through Rstudio. You can just go new script. And you can open up Finder or Windows Explorer and drag around, copy and paste different files into the right places. Okay. I've just used the command line terminal here because it's super quick and easy for me. But whichever the way to do it that works for you is totally fine. Okie dokie. So Rstudio Git integration. Okay, so we're now going to pretty much follow this up by creating the Rstudio equivalent. So I'm going to go to this, and I'm going to go to new project. I don't care about this. Version control, Git, and we have no. We have this. Okay. And we can just put this on our desktop and I'll create the project. Okay. So I just created this new project based on this thing that we just made. Okay. And so we have the Readme here as well. As we pointed out earlier, this is because I'm doing it in two different ways. This isn't really how you set up a project, right? Because we created it locally, then we pushed it online, then we're adding it to Rstudio. These are two separate ways of doing things. We're just doing it to the same object. Okay, so we go back to our questions. We've created the version controlled and we've saved it in a different place with update to include a TV show. Well, the TV show was already there, but we can add more TV shows, I guess. I don't know. Mandalorian. There we go. There's a TV show. And we can then go into the Git section, and we have these two, which were part of establishing the R project. So we can save those set up R project. We'll commit those as one commit because they're their own little thing. And actually, it wants us to do some other stuff before we add stuff. Okay, so the next thing, we've added that. Then we want to create a new R markdown. Okay, with this, within this source the day of the week R script. Okay, so this actually relates to some of the stuff that we haven't covered yet. Okay, so this touches on reproducible reports and how to use them. But I can show you really quick what we're talking about. So we create a new R markdown. This is a specific kind of file that are really useful. We can call this test again, or just everything's called test. Okay. And what we're going to do in this, I'm going to delete this. It creates a bunch of like demo data inside of it. But these are the type of files that we use to okay. So these are the type of file formats we use to make reports. And the reason we use these to make reports is you can turn it into a nice HTML. Okay. And so here we have these little chunks, and each of the chunks contains our code that we want to evaluate. Okay. So I'm just going to save this. And let's test it. And what we can then do is if you press the knit button, it'll create a HTML file, okay? And in it we sourced, oh, but we didn't run. Okay, we should then run the command. So in day of the week, we have a function called day of the week. So let's run it. Okay, and so the nice thing about this, we'll knit this again. So it runs all the code. So in this, we source this R script. In it, there's this function. We evaluate the function, it saves the output, and we have all the session information here. So this is all the packages we used and things like that. And so this is a nice HTML file. So we could open this up in Google Chrome or whatever web browser you want to use. And it contains all the information about R, how we ran it, what we actually ran, and the outputs, all in one file. So that's a preview for what we'll be doing soon. Okay. And so really what we want is the HTML file. Okay. The HTML file is the most useful part of this because it's the report we generated. And we actually want to ignore the Rm Git because that's our code. So maybe we don't want to put our actual code online, but maybe we want to put the output online. So we can save this. And so we've now updated our Git Ignore. And it's not showing up. So we'll do refresh. There we go. And so when I clicked refresh, you may have noticed that now I have .git ignore up here, and the test.rmd, even though I haven't added it or committed it or anything, it's no longer here. And that's because we're ignoring it with the .git ignore. And so this whole section really is something we did all in one go, and it's a contained project. So let's say we can commit it all together. And so these are Git exercises. And so we commit them all together. They're all annotated together, and then we can push it. So now it's up on GitHub. Okay, so that's section 2. And then the final section is relating to this repository here. Okay, so in this repository, it's a training example to help you practice using GitHub online, okay, and how to collaborate online. And so we want you to kind of use the workflow we talked about. And so first off, you'll take a fork. So I take a fork. Okay, it takes a sec to load. And what we want to do is I want people to add various GIFs or GIFs to here relating to how this training has made you feel. It can make you feel terrible, wonderful, ambivalent, whatever you want. Just upload a GIF, okay? And so the way we'll do that is, let me see, where's the issues? Oh, yeah, we'll take a fork first, and then you'll actually want to go to the original one, and there'll be an issue. And so you can put a new issue. Okay, saying what kind of GIFs you like. I don't know. I want more ironic GIFs. Okay. Okay, and so I know this is all like pretend and it's not real and it's a bit goofy, but all the same processes you're doing with this are the same as what you do in a real project. So it's a good simulation with, again, low stakes. Okay, so I need to find, okay, then I can go back to my fork. So we've done an issue. You can comment on the issues, you can look at create new issues, but just explore the issues somewhat. And then we can go onto Giphy, we can find a GIF that we like. So I feel today great. It's being very slow. Oh, my internet connection is struggling. Okay, well, we'll just stick with what I can see, which is a nice Napoleon Dynamite GIF. Oh, no, it figured it out. Okay, we'll go for Sigourney Weaver instead. Okay, and so you find the GIF that you like. And so in this case, we can then copy the link. And then we can edit this. Okay, so we'll just keep it simple. And we'll do edit. And you can just copy what we have up here. So I'm going to copy this. This is just some HTML to embed it. And you can put your GIF link inside here. Okay. And you can say, adding the changes. And now it's added. Okay, and so now I want to do a pull request. New pull request. And I'm now going to pull it back onto the BRC main page. Okay. You can add extra comments if you want. Okay, and so you won't get this option. I have permission to merge pull requests and you guys don't, because I am an admin on this, repository. But if you submit a pull request, I'll check them every so often and I'll add them in. But through this process, you'll be able to see how we typically work online with GitHub, okay? I'd say the key elements though, like this is a nice simulation if you think you're going to be doing some online GitHub and need some practice just to feel comfortable. The really big things are the first two sections, okay? This one's a nice little bit of extra fun. Okay, so that is the run through of the exercises. If anyone has any specific questions, feel free to pop them in the chat. And I'll have a look through the message now with Esther. If no one else has anything simple they want to ask. Okay.